Hello and welcome to this new video tutorial. This time we are going to be covering the Wilcoxon Rank Sum test. Wilcoxon Rank Sum test. This test is the non-parametric alternative to the t-test for two independent samples. What do we mean by the non-parametric alternative? Well, whenever you cannot use the t-test for two independent samples for whatever reason, then you should consider using the Wilcoxon test for the rank sum Wilcoxon test. So when would you fail to use the t-test for two independent samples? For example, when the normality assumption is not met, right? That could be a problem. So in that case, you use a non-parametric version, in this case the Wilcoxon Rank Sum test. Or for example, when the data is not measured at the interval or ratio level, which could happen because you could be measuring ordinal data, and ordinal data is not enough for the t-test. T-tests require at least interval data. Now, I don't want to get into the distinction between ordinal or interval or ratio or whatever. That's something you probably should go back to your book and take a look. But normally you know when to apply the test. You're given the data. You're given two samples. And all you know is that the t-test cannot be applied, so we just apply the Wilcoxon Rank Sum. And we need to specify two things in order for the solver to run and to run properly and find the solution. You need to provide the sample 1, the sample 2, and the significance level. In order to make it more concrete here, I am going to pop up here a sample problem of what would be like a problem that would be solved with a the Wilcoxon Rank Sum. So let's take a look at this problem. It says, over the past 12 years, statisticians have kept track of the total number of academic scholarships awarded to the Valley View High School seniors and seniors at the rival school, which is the Ocean View High. So you have two samples here, right? So in a way, you want to compare these two samples. They're giving you they're telling you the significance level is 0.05, and you want to assess whether or not there is a difference in the number of academic scholarships. So you want to use the Wilcoxon Rank Sum test, and so you take the first sample, paste it here, and then you take the second sample and you paste it here, sample 1, sample 2, and the significance level there, they said, is 0.05. So we find it here, 0.05. Now, see that they want to test whether or not there's a difference. So this is a two-tailed test because they're not wanting to know which one has more or less. They want to know whether or not there's a difference, and that's always as stated as a two-tailed test. So what else do you have to do? What else do you have to do? Nothing. Just click here on solve, and voila. You have the data, you have all the procedures you follow, you order the data, you find the ranks, you adjust for ties, remove ties, compute the sum of ranks, compute the test statistics, determine whether or not you can use normal approximation, rejection region, the statistics, the test statistics, the z-test in this case, because you use normal approximation because probably the sample sizes are large enough. And then here you have the conclusion, and here you have the graph. Beautiful, beautiful solution. What do? Just I want to copy it and just paste it in whatever word processing software like Word or whatever, OpenOffice, whatever you want. And as usual, you can change this and the problem will update with a new solution based on the change that you provided. You can delete data, you can do whatever you want, modify this, change it to a left tail, right tail, whatever you want. Or you can start over. As usual, here at the end you have the the start over button that you just click on, and then it starts over. All right, that's all for now. See you in the next one.